working on a set of problems here that deal with simplifying expressions with exponents, essentially. So this is the first part of first video, of a two-video series on simplifying exponential expressions. So we're going to start off with applying the basic rules of exponents in this video with these three problems, and then we'll get to more complicated questions in the second video. Okay, so I have the following three problems, and all of these problems are going to involve one of these exponent rules here. Okay, so we're going to be following the following rules of exponents. So first rule of what we have is, if you have an exponent a to the b times another exponent a to the c, it's equal to the a, b plus c. Essentially what it says is, if you have two exponents with the same base, the base is a, and you're multiplying those two exponents together, it's equal to you summing the exponents together and keeping the same base. Second rule, number 2, says a to the b divided by a to the c equals a to the b minus c. And this says that if you're dividing two exponents with the same base, it's equal to the exponent raised to the difference between the exponents. So it's like you're subtracting them. And then finally, rule number 3, it says if you have an exponent a to the b and it's raised to a power, so it's like an exponent raised again in a way. Some people like it in a way. So you got a to the b all raised to the c is equal to a to the b times c. So basically you have an exponent, raise it to a power, it's equal to the product of the two powers, one on the inside and the outside. Okay, so we're going to apply those rules here. When you're looking, very important, these rules only apply if the expressions have the same, for rules 1 and 2, if the bases are the same, they cannot, if you have different bases, then these rules don't apply. Okay. Now, for this first problem, we have x to the 7th, y to the 9th, that's one quantity, times x to the minus 2 times y to the minus 11. So out of these three rules, I'd like to go ahead and find which one would apply. It doesn't look like any one of these applies, and that is certainly the case. It may not look that way, but we will make this expression look like so we can apply this. So I'm going to rewrite this as x to the 7th times x to the minus 2 times y to the 9th times y to the minus 11. So I grouped the x's together and I grouped the y's, and we're allowed to do that by properties of commutativity, associativity, etc. So we're allowed to do that here. So we have x to the 7th times x to the minus 2. These exponents have the same base, so I'm going to go ahead and add the two exponents together for the x. And I'm going to do the same thing for the y. Y to the 9th times y plus minus 11. Here. And if we went ahead and did the math, 7 plus minus 2 is like saying 7 minus 2, which is 5. And then y to the negative 2 is what we have left. So that's your answer. Now, often it is the case that you don't have to put the parentheses anymore here. You can write this out with positive exponents or negative exponents. It's more common to write answers out with positive exponents only. And the way we do that is, by definition, when you have a negative exponent, you put it under 1. So 1 over y squared. So that's just the definition of having a negative exponent. It's that you put 1 under it. And you would have x to the 5th over y to the 2nd as your final answer. Okay? And that's how that would look like with positive exponents only. And then I'll stress that for these problems. So I'm going to move on now to number B here. So we've got z9, y3, copy that, and then over z to the negative 8, y to the 10th. Let's just paste that here. Okay. And for these, this expression right here, I'm dividing these two expressions with exponents. And yeah, because I'm dividing exponents essentially, I can use rule number 2. And the way this is going to work is that you're going to kind of separate the z's from the y's. So this is going to be z 9 minus negative 8 times y 3 minus 10. So this becomes z to the 17th because 9 minus negative 8 is the 9 plus 8. And then 3 minus 10 is equal to minus 7. And let me just, so kind of taking the work with z step by step. So it's z to the 17th, y to the minus 7th, which becomes z to the 17th over y to the 7th. So again, I bring down the negative exponent. Now, I did not make the move where I put 1 under y to the 7th like I did in the last problem, because you actually don't really need to do that. It's equivalent you just putting the y under the z, but you change the sign on the exponent to positive 7. Okay. All right, and then last but not least, we have our third problem, which was x to the third times negative 5 times y 3 to the minus 2. Okay, and for this problem, I'm going to use C. I have two exponents raised to exponents to an exponent, excuse me, and I'm going to go ahead and use the rule which says, look, what you can do is you can multiply the powers here. 3 times negative 5 is negative 15. Negative 3 times negative 2 is negative 6. I'm sorry, positive 6. And that is it. In terms of, you can't really simplify this in terms of adding or subtracting exponents or anything like that. But what I can do is I can put the x to the 15th under the y to the 6. Again, because negative 15's 15's got a negative in front of it. Put it down below the y to the 6, and that is your answer right there. Okay. So these are some problems involving the basic rules of exponents here. Again, let me just refer back to them. And very important, once again, you have to have the same base with them. In my next video, I'll go over some more complicated examples with exponents that we'll take a look at, which will basically combine a lot of the rules that we're using here. Okay, thank you for your time. Hope this helps.